What you're about to see is a LandingLens product demonstration aimed at an audience of subject matter experts. In our case, we'll be thinking about the utility inspector, who has expert knowledge of identifying birds' nests on transmission lines, but is unfamiliar with computer vision and machine learning processes and development. Let's see how a team of utility inspectors can apply their expertise to develop a computer vision algorithm, often in as little as a day. I'll start by creating a new project, and I'll call my project Bird Nests. This will be an object detection project, so I'll leave this option checked. Then I'll select the first 9 images from my file system and drag them into the center of the screen. The data we'll be using today is shared under a Creative Commons license from the authors of deep learning-based bird's nest detection on transmission lines using UAV imagery. We thank you very much for sharing your data. Back in LandingLens, my first step is to create a class. I'll call it Nest. And return to the build process. Now I'll select the first image and draw a bounding box around the nest. I'll check carefully for a second or third one before moving on. It's important to keep your bounding boxes tight around the object of interest. Now I'm using the arrow keys on my keyboard to switch between images more quickly. This image has 2. Ten images now have labels, and all of the work is being saved as I go. Let's return to the project view. 10 labeled images is the minimum to train a model, so let's go ahead and auto-train this first model. LandingAI's proprietary technology allows you to achieve excellent model performance using fewer images than are typically needed. The first model training is done, and we can learn more about it from the model card. Let's view the full report. Here, we see that it took about 28 seconds for the model to converge on optimal performance. In the performance report, we can compare images side by side. All the pictures on the left are the ground truth. These are based on the labels that I provided drawing the bounding boxes. The pictures on the right, using the dotted lines, are the predictions from the model for where the nest is located. The metrics show that the model was correct for 9 out of 9 predictions in the training set and 2 out of 2 predictions in the development set. Now, don't get too excited about these 100% using only 10 images. Your professional inspection team would be unlikely to trust the outputs of such a model. Let's go back to Build, add more images, and also get our utility inspectors involved in the labeling process. I'll select the Upload icon, and I'll bring over 30 more images from the file system. Preview looks good, so let's upload those. Did you notice the message that 7 images failed to upload? Even though they had different file names, they were actually visual duplicates of other images already in the project, and LandingLens detected that for us automatically. At this point, we have 33 images, and the histogram icon shows us a quick data summary. 10 are labeled, 23 are unlabeled, and so far we have 11 nests. Let's assign the 23 unlabeled images to our professional inspectors. First, I'll filter on media status and choose unlabeled. Then select all 23 pictures. From options, I'll create a labeling task. And I'll say that this task is for onboarding to get them started. I can choose to have each image labeled by one person or multiple people. Let's say that we have 2 inspectors and we want them all to label all 23 images just for practice and onboarding. We select their names from the drop-down list and then create the task. This will send them an email notification, and because I assigned some of the tasks to myself, I also see a 1 here in the task list. From this view, I can see the work assigned, and from this view, I can see the part that I've assigned to myself. From here, I can go directly to the task. To onboard labelers, there are some additional animations and instructions to get them started. I'll select the Nest class, and I'll settle in to do some labeling. Using the forward and back keys on your keyboard makes this go pretty quickly. Let's say that I needed to stop midway. I've labeled 7, I have 13 to go, but I can submit the 7 that I've already done to be reviewed. Let's exit out of this view and return to the task list. Here you see that the overall progress across all inspectors' work is 15%. LandingLens makes it easy to assign and track this type of labeling work. It's a great way to tap into the knowledge of experts who may be working in different locations or working from home. Let's return to build. Now we're seeing the pop-up label in task on top of some of the images to remind us that these have already been assigned out. At this point, I'm not going to label any more images myself, but rather I'm going to take advantage of the expert labels that were already done by the researchers who shared this data. Notice in the text here that we accept image formats and also the Pascal VOC label format. Next, you'll see me upload images and their corresponding labels. I have the images and the annotations arranged into folders, so I can simply drop the folders into the upload area. As you see the images populate, you now see a greater diversity of angles, distance, and background. All right, uploading is done, and here's our quick upload report. I'm not surprised that a few of them could not be uploaded because they were already in the project from the work we did earlier. So in our data summary, now we have 368 labeled images, a couple that are waiting in that task status, but we're going to go ahead and train a model on these 368, which contain 404 labeled bird nests. From the Train menu, there is an option for custom training. I'm going to show you some of the advanced configurations available here, but then we'll go back and do just the automatic standard train. In this view, you can manually configure your splits by train, dev, and test set. And in this view, you can edit the number of epochs, choose your model size, apply transformations including resizing and cropping to the images, and select from a list of data augmentations. All of these options are configured for you under the hood when you just choose the basic training option. Let's go ahead and start it now. Training is now in progress for version 2 of this model with a greatly expanded dataset. LandingLens will snapshot the data for governance and reproducibility purposes. Then it'll spin up the GPUs required to train a computer vision model. The training process itself goes through multiple epochs. Don't worry if that doesn't mean anything to you. And once the training is done, we can calculate the performance on the new model. Let's click on the model card to follow along in more detail. To interpret the loss chart, what you need to know is that lower is better on the error metric on the y-axis, and the x-axis here represents both time and epochs completed. Training is nearly complete. Let's switch over to the Models page. Model training is now complete, and it took about 9 minutes of elapsed time. We now have a second entry in our model summary board, and this 98 and 95 are much more realistic numbers to expect. These are both excellent. So let's unpack these a bit further. We'll click back into the model and ask for the full performance report. And we can go full screen. In machine learning, the training set is used to teach the model what to look for, and the development set is used to evaluate how well the model is learning. The performance on the development set will be more indicative of performance in the real world. Here you can see that there's 75 images in the development set and 81 instances of birds' nests. That 81 is broken down as 74 which were correctly identified and 7 which were missed. A false negative is a place where the ground truth says that there is a nest, but the prediction is null. Note that there are no false positives. A false positive would be a case where the ground truth is null, but there's a prediction that a bird's nest is present. Let's click on the number 7 to view the false negatives. I'm not a professional inspector, so take my commentary with a grain of salt. But this nest on this background is very hard to see. This nest from this distance is very hard to see. And something like this would be easier to see against a blue sky background rather than against this vegetation. Let's take a look at a few of the correct predictions. Here, in addition to the prediction, we see the confidence threshold. 0.99, 0.96. Those are some obvious bird's nests. Here we've got a 0.98 and a 0.89. Have your inspectors participate in the labeling and participate in the review of both the incorrect and the correct predictions to help them gain confidence in what the model has learned and its ability to assist them. Note that the confidence threshold is adjustable. By adjusting this up or down, you will see the overall performance metric change. For example, if I set the confidence threshold to 0.9, then this prediction at 0.89 and this prediction at 0.8 would no longer be predicted. You can use the confidence threshold to ease in on end-user adoption. For example, you might choose to bypass human inspection when the confidence interval is very high. In this case, it would have saved the inspectors 62 images that met that very high threshold, which they would not have had to look at. I'll put the threshold back to 0.55. Notice that when I add that confidence threshold, I have a new entry in my table. This is not a different model, it's just a different cut point for how you want to use the model in practice. These are all choices that you'll make when you move to deploy the model. Let's give the top model the yellow star and move on to deploy it. At this point, you have three options: cloud deployment or two different self-hosted deployments, either using Docker or using LandingEdge. To keep this video focused on birds' nests, we won't explore all three options. We have other videos for that. I do want to end by looking at the accuracy reported by the authors of this paper that provided the images. In their data preparation section, they note obtaining 3,000 images versus we were working with about 400. In LandingLens, you saw the F1 score being reported as 98% on the train set and 95% on the dev set. Recall that we had a few false negatives, but we did not have any false positives in our prediction. Let's take a look at their reported results. They tested multiple methods, but their best F1 across all methods was just shy of 55%. The work we've done in one afternoon in the graphical user interface is beating all of this detailed hand coding. Working with a subset of images and the same labels as provided by the paper authors, we've achieved a much higher F1 score. This is part of the power of LandingLens. It's not just easy to use, but it produces better models. If you work in the utilities industry and would be interested in visual inspection for birds' nests or any other visual inspection task, please feel free to contact any of us at LandingAI. Thank you.